Welcome to this decarbonization showcase hosted by NYSERDA's Empire Building Challenge. Its purpose is to familiarize you with technologies and strategies to facilitate decarbonizing our building stock. All sessions will be recorded and posted to the EVC Showcase Series website. Each presentation will be 20 minutes, followed by 10 minutes in which the presenter will respond to your questions, which you can post in the webinar chat. And now it is my pleasure to introduce Chris Fraughton of AtmosZero.
Thank you, Saul. So my name is Chris Fraughton. I am the Senior Director of Sales here at AtmosZero. Been with the company about a year, and we are taking innovative steam boiler technology, or I should say steam heat pump technology, into the boiler room. If you want to flip to the next slide, and I can kind of give you a little background as well on AtmosZero. So we are a 3-year-old startup out of Colorado. We started in Colorado State University. The lab and one of our co-founders is actually a tenured professor at CSU. And when you look at decarbonized steam solutions, obviously there's electric boilers, and now there is steam heat pumps, but cost is the number one problem with decarbonizing the existing building stock and process steam industries, food, beverage, distilling, etc. So what we're doing as a company is really trying to tackle that in 2 different ways. One, high efficiency compressors and high efficiency heat pumps, so we can have higher COPs in comparison to theoretical limits, as well as a very standardized modular product. And so when you look at the steam heat pumps that exist today, there is some good technology out there, but most of them are custom heat pumps that are quite expensive, very large, and it becomes a pretty big integration project. At AtmosZero, we're taking a standardized modular approach while keeping the flexibility to tie into any existing facilities. You can flip to the next slide. So what we're doing is we're a hybrid technology in comparison to what exists today. So, and why I say hybrid is we're still electrified and decarbonized, similar to resistive or electrode boilers. However, because of the efficiency gains you get with heat pump technology in general, we are a much lower cost option from an operating standpoint. And so, that's kind of why I always tell people we're a hybrid between the combustion boilers and the electric boilers that exist on the market today. You can flip to the next slide. So we have a pretty robust R&D pipeline as a young company. Our products are getting better every day. However, today we have one product, which we call Boiler 2.0, which is a modular air source steam heat pump. Again, modular, mass manufactured, capital efficient, and also relatively small building blocks. We're a 1 megawatt thermal system, and depending on the COP, we'll give you the electrical input. The air source part is optional. We go to market as an air sourced heat pump for a few different reasons. It allows us to be fit into any building or any application, if you will. We don't need waste heat. However, our system is designed in a way that we can easily integrate waste heat if it's available and sufficient quantities. So, we can also liquid source these units. The steam piece of that statement is really the focus of the company. So we're focused on steam. However, we do occasionally get interesting hot water cases. So if you have a very high temperature hot water, 180 Fahrenheit or above, that you can't find a solution for given the capacity and constraints of your building, we will look at those on kind of a case-by-case basis. And then the rest of that kind of explains, the air source nature, right? The right side of the screen there, you can see a picture of the unit. This is a tiny bit smaller than what we actually bring to market now. This is a 650 kilowatt unit that's sitting at our facility in Loveland, Colorado. That unit is actually operating today at New Belgium Brewery in Fort Collins, Colorado. We will talk about that shortly. But you can see it is a 2-piece setup. So you have the air coils that will show up on a truck in the case of an air source system. And then that blue and orange box at the bottom is the entire heat pump package that shows up just like that. You lift it off a truck, you put it into place, and the installation and integration of the equipment at your facility is very, very quick. You can flip to the next slide, please. So this is a schematic of what we have from inside the box, if you will. So it's a cascaded heat pump technology. So you have basically two heat pumps in one. You have a low temperature cycle running off an A2L or an A1 refrigerant. And then you have a high temperature cycle running off an A1 refrigerant. In both cases, we can keep the GWP under either low or ultra low, depending on what the requirements of the customers may be. If you look at the right side of the screen there, that is the condenser and the heat sink side. So we're taking feed water in, the exact same feed water that you typically have in a boiler room today. So anything you're making steam with today will work fine for these condenser, from a water quality standpoint. The steam that comes out is either 60 psi or less right out of the heat pump. So for building stock, that works fine. If you run into more processing industries, sometimes you'll have higher psi requirements on the steam systems. We have a couple options there. We can either add an MVR and boost that pressure to the specified requested pressure, or we can look at tying that lower pressure steam around some pressure reduction valves in a facility. We've done both, and we're kind of advancing projects in both directions. The left side of the kind of double heat pump thing you see there is the evaporator. One thing very specific to AtmosZero is you will see that glycol loop that goes into the air coil. The glycol loop is some of the magic bullet and IP that we have in the company, in the sense that we can keep the refrigeration or the vapor compression loops the exact same for every single different facility because of that glycol loop. What we're doing is we're varying the flow to match the heat rate of that evaporator to keep the compressors of the heat pumps where they need to be on their operating curves. And so whether you have a heat source that is 20 degrees Fahrenheit or 80 degrees Fahrenheit, that glycol is what allows that flexibility into a facility. Last but not least, you'll see the air coils on top. So we have a 6-cell air coil shown there. The air coils do come default with defrost capabilities, so you don't have to worry about that high humidity, very low temperature section and frosting up coils. In the case of a water sourced unit, that air coil goes away. You put a tiny little plate and frame heat exchanger pretty much where that first cell is on the left, and you can tie in any kind of processed water or waste heat that you may have. A lot of projects look at using cooling towers, look at using the condenser returns off chillers, or sometimes process cooling directly. And we can achieve higher COPs, but it typically takes a little bit more integration on the customer side. You can see some specs there. So I mentioned, if we go from the top to the bottom, we are a 1 megawatt thermal system. We can do a little bit less. So in the case of a building where you have like a 15 PSI system, just based on how the math works out, it's a little less than a megawatt. It's probably closer to like 850, 875 kilowatts. These are 480 volt systems, so low voltage 3-phase power. 1 megawatt is about 3,400 pounds of steam per hour. And so we can turn that down as well, about 30%. So you can go from 100 to 70 without any efficiency penalties. You can turn down further, but that's where you start running into COP efficiency penalties. Steam pressure and temperatures, we talked about that. Air source, talked about that. Inlet air temperature, I will skip for now. That's a good segue into the next slide. The dimensions. So this is a somewhat large unit given 105 boiler horsepower. It's 8 feet wide by 27 feet long. And to the split line between the air coils and the top of the heat pump there is about 9.5 feet. And then when you add the air coils, it's about another 9 feet. So you do need some space, or most of our clients actually put these outside completely, which we will talk about in a second. Refrigerants, I've touched on that. The low temperature cycle, you have options. So in New York and other places, a lot of clients are looking at ultra low GWP refrigerant options. That is the A2L that I mentioned. So we can get the entire refrigerant quantity on both cycles under a GWP of 10 by using that A2L fluid. If you would prefer a A1 type refrigerant, then your GWP is roughly 300. You can flip to the next slide. So here is, the money slide, if you will, for most engineers. They're very curious about the COP profile that we can do with our equipment. The x-axis here is ambient temperatures. So if you're an air source system, you're going to walk up and down this curve throughout the year. The y-axis there is obviously the COPs. The yellow line on the top is probably more indicative of a building application. So that's about a 15 PSI discharge. And then the 60 PSI orange line is more in line with what you'll see in some processing, food, beverage, pharma type facilities. If you do tie this to process cooling or waste heat, you can actually still use the same chart. So this is the air temperature or water temperature entering the exchangers. And so in the case of a cooling tower where you have, call it 70°F water coming in, you'd be about 21 Celsius, and your COP on a building would be a little over 2 typically. One thing that we do is we will run case-by-case analysis. So if you guys have an application that you want to take a look at, you can send me an email. I'll send you a questionnaire. You can plug in some information around steam profile, energy pricing, and footprint, and then we will give you a very site-specific technical and economic output to show you kind of how we compare both technically and economically versus electric boilers and gas boilers. What else? Maybe one last comment here is, a lot of times people say, okay, so what happens if it gets too cold? So you can see on the top bar there is Celsius, the bottom bar is Fahrenheit on the temperatures. If you get below -20°C or -4°F, what happens is your COP starts to come down pretty quick, and we basically turn into a resistance boiler. So the low cycle of the heat pump stops sourcing heat from the air, and we run that cycle and recycle, which then heats the top side, which then still makes steam. So it's not an issue of will it work, it's just an issue of efficiency. And so in those very cold temperatures, we look at that as part of the analysis that I mentioned to see, how many hours a year we're going to be operating in those cases, and we can make decisions accordingly. You can jump to the next slide, please. Installation options. So most of our customers are looking at that top left outdoor installation. They keep existing assets in place, and they're trying to reduce Scope 1 emissions with heat pumps. It kind of is a good option for also lowering steam costs, because you can arbitrage around demand periods, and you can arbitrage around renewables or any carbon metrics that you might get from the grid by having both assets in place. Plus you have the reliability of gas as a backup. And again, that's probably 75% of our current projects are looking at outdoor installations like that, to where we're just putting 3 pipes through the wall: electric, feed water, and steam. The split installation on the bottom, you can see the air coil is kind of outside and the heat pump's inside. That's also an option. One interesting point here, whether it's a water sourced or air source exchanger at a different location, the piping between the heat pump and the exchanger is actually glycol and water. It's not refrigerant. So it's a little bit easier from a refrigerant management standpoint. And then obviously on the right side there, you can see some campus type settings where we can come in and put steam generators and on a building by building basis rather than a central plant. We do that to either add capacity to a system, or a lot of, especially college campuses are looking at hot water discharge or conversions, and we come in for those life science buildings and hospitals to where they need steam. Central steam plant there, bottom right. Today, I would say we're a little small given the applications we typically see on central plants. We do have some ambitions by 2029. We're going to have a larger unit, about 4.5 megawatts. And then central plants built around our technology make a little more sense. But having that said, when you do stack a lot of smaller heat pumps, you actually get a lot more turn down capability than you would by putting in a few larger heat pumps. So it depends on what the steam profiles of facilities look like to see if that's something that you want to pursue. You can jump to the next slide. This is New Belgium. If you've been following AtmosZero for any time, I'm sure you've heard about this project. So we are taking a third of the steam demand of the facility away from gas and putting it on a base load of our AtmosZero heat pump design. Again, this is a tiny bit smaller unit. This is a 650 kilowatt unit. One of the things that we really wanted to do with this project, though, was to prove to the market we can install a unit with zero downtime, which we successfully did. There were some double block and bleeds installed at the facility, which allowed us to tie in the piping and feed water lines in advance of the heat pump showing up. Once we shipped the heat pump, given we're only 45 minutes away from Fort Collins, it was shipped and installed in 1 day. Mechanical and electrical completion was about 4 days. The commissioning and commercial operation was about 2 weeks, and that's to get our boiler in line with their existing gas boilers, which they have a few different technologies there. One thing that's kind of interesting with New Belgium too is we wanted to test the turn down capabilities of our unit, and it's probably typical in a lot of places, but they have a very, very small steam volume. So you actually see when their steam equipment comes on, or steam uses come on, they have very large pressure swings. And so our equipment's been able to handle that quite well, even with swings up to like 850 kPa. And then, yeah, so if you've ever had a Fat Tire Voodoo Ranger beer, as of June 22nd, they're a bit more decarbonized. And then maybe we jump to the next slide. I think we got a couple more minutes left before Q&A. This is some specifications. The main story here is really around the connection points. So to your facility, you really only have 3 mechanical connections and 4 electrical connections for power and data. Outside of that, the whole unit comes ready to go. And if we're shipping in the US, we'll also have it loaded with refrigerant. So it's really plug and play when it gets to site. If anyone's curious about the specifics on specs, you can reach out to me and I'll get you a better spec sheet than what I'm showing you here. You can hop to the next slide. One more, actually. This is just an update on where we are as a company. So I mentioned, young startup at the beginning. So we have grown to the point where we actually opened a 100,000 square foot manufacturing location in Loveland, Colorado. So this is where we produce our compressors and assemble the units, as well as have a fully controllable, customizable test stand. And yeah, today we are capacity constrained as far as production, which is somewhat of a good thing, but we will be raising a round of funding in the coming months to increase the production capacity of this facility by hopefully to 100 units a year by middle of 2028. And I think the last slide you can jump to. Yep, just kind of the summary. If everything you heard today went in one ear and out the other ear, the main thing to remember is, Boiler 2.0 is a product, not a project. Think about it much more like an HVAC install at your house than a large industrial construction project. We're really trying to package those industrial needs into a off-the-shelf product. And with that, I would say let's open it up to Q&A. And there's my email, by the way, at the bottom left there, in case you want to reach out and dig in a little deeper. So I'll pass it back to you, and
Great.
we can do some Q&A maybe.
Perfect. Yeah, we have a bunch of questions come in. I'm going to read through them quickly.
Sure.
Let's see. First question is, how many pounds of total refrigerant, I assume this is the system, carry?
It's a great question. I can give you an estimate because there's actually a condenser redesign going on, and I don't have the 99.9% accurate number in my head, but it's roughly about 1,000 pounds. You're about 500 on each cycle. Should we jump to the next one?
Yeah. Let's see. Do you use inverter technology?
Inverters. We take 480 in. We actually have drives inside the unit that convert that electricity into, for our high-speed motors. And so inside the drive topology, you do have inverters, but I'm not sure that's really the intent of the question. So I would kind of say yes.
Yeah. I'm going to go to the next.
Okay.
Does it require any special steam piping configuration at the outlet?
No, we're really a drop-in technology to where we're going to tie right into your either distribution header or into some lower pressure leg of a distribution system. In the case of buildings, wherever you're putting your boiler output today into that manifold would be the same place we would tie into.
Great. Going back to slide 7, why does the steam temperature increase for the examples on the right side of the slide?
Maybe we flip back. So steam temperature increase.
Danny, you want to go back to slide 7?
Yeah, maybe that's the COP curve.
Yeah.
I can't remember.
Correct.
So that's just showing two different profiles. So when as I mentioned, this unit is capable of producing any amount of steam up to 60 psi. And so depending on what your output pressure is, it will be, kind of what we have the COP profile look like. So that was just two examples. And I think 7 still 2 more slides back.
Yeah. Next question, which was related, is the AC boiler trimming base loaded? How is it making 1/3 of total steam load?
Yep.
I think was the following slide. Yeah.
Yep. Yeah. So we ideally like to be base loaded. All heat pumps prefer that. Compressors have a limited operation curve that you can run on, and so that is actually what dictates the turn down of a heat pump, regardless of who you buy them from. We are centrifugal compressor technology, which has even a little bit. They're much more high efficiency compressors. They have a little bit less turn down than like a recip, as an example. But yeah, so the facility in New Belgium is about 7,000 pounds an hour. And so we are, on average, 1/3 of their steam demand is what we're kind of adding into the facility. As I mentioned there specifically, they do have very large swings in steam pressure. And so while we can turn down to a point when those steam demands get bigger than what we can handle or smaller than what we can handle, we'll turn those units off. Or I should say smaller. When they get bigger, we just run base load, basically.
Question on capacity and on the price compared to regular heat pump chillers.
Capacity, so we're 1 megawatt thermal system as a nameplate. There's, call that a nominal number. Again, it depends on what the steam output pressure is. So if you're a lower pressure system, that'll be a little bit smaller, anywhere between like 850, 900 kilowatts, which is about 3,000 to 3,400 pounds an hour. But then from there, you also have turn down. So to give you a rough range, call it mid 2,000 pounds an hour to 3,400 pounds an hour. What was the second part of the question? Sorry.
The price comparison with heat pump chillers.
I've been in steam heat pumps for a very long time, so I'm not super familiar with heat pump chiller prices. But I will say we are roughly $700 to $1,000 a kilowatt. It depends on how much bells and whistles you kind of want, and what the sourcing technology is. Yeah.
Great. What has been the NB-AZ broiler COP performance so far? Do you have any data performance summaries yet?
We do. Not something I can share broadly on a webinar, but if you shoot me an email, we can kind of go through some of that detail. We have done very, very well compared to what we've modeled. So on the lower ends, the very, very cold temperatures, we have less operating data just because it hasn't been that cold since we've been operating these units yet, even in Fort Collins. And on the upper end, we are actually outperforming what we have modeled. So yeah, I would say relatively good COPs.
There was mention that D rate below 70% further reduces COP. Can you give a rough approximation of the percentage reduction in COP?
Yeah, it's pressure dependent, so it's a little tricky, but just to ballpark it, down to 70%, you generally don't have any COP hits. Between, call it 50 and 70% turn down, you're starting to approach, 1.1, 1.2. So it's a pretty significant hit in COP. And then below 50%, you really kind of need to turn the units off because the compressors are starting to run and choke, and you will get, you could potentially damage the compressors. And so our control system takes care of all of that. You don't have to worry about it, but it is something that we're going to set up and talk to you about during the commissioning process.
Is the application mainly intended for commercial sites rather than residential?
Yeah, we don't do much residential well, I guess you could argue multifamily, stuff like that, or like very large residential could be an option. The typical problem with that, though, is there's a heating season. And so if you're going to spend a lot of money on a piece of equipment, you want to run it year round. And most of the kind of residential applications I've seen so far just don't have enough operating hours through the year to make sense. It might be running 4 months a year or something. So I would say it's case by case dependent, but really the ideal situations are where you have, a steam load year round.
Can the system make 180-degree Fahrenheit hot water instead of steam, or would you need a heat exchanger?
We can. So that's what I mentioned, case by case. I'm learning that's actually a bigger market than maybe I had understood at the beginning. But yeah, so if you have one of those applications, I would say reach out to us. Assuming the hours are there and some of the other pieces of the puzzle check out, then yeah, we can do a 180F application.
Can the system respond to demand response signals from the grid?
It can. So the entire system's actually can be remote monitored and remote operated. It turns on and off very quickly. So from a warm start, you're under 5 minutes to full pressure steam. And from a cold start, you're about 10 to 12 minutes to cold pressure or to full pressure steam. So it is a pretty quick response time.
Can the unit generate steam at lower than 5 psi?
Yes. I need to double check, but yes. We have an application that's like a 3 psi output, and I don't know where it is honestly, but my understanding is yes.
What is the outdoor temperature? You said it required to shift to resistance.
Today, we make the cutoff at -20. We're looking at extending that in the near future. I mentioned R&D pipeline. One of the things they're working on is kind of a partial hot gas bypass, to where you can start still sourcing a piece of the energy from colder temperatures than that. And so that's just going to be a software update that will push to all the units probably in 6 months. But as of today, call it -20F. Or sorry, -20C, which is -4F.
Great. So we have a time for a few more questions. Does it carry limitation on inlet water temperature or delta T supply and return?
It does not, because we are really managing that through the glycol loop. However, if you on your facility side have a tight specification on what that delta T should be, we can also vary our glycol loop accordingly. It just, it's something that we need to scope out and discuss kind of early on in a project.
Great. So one last question we have time for. Is there only one installed project that you all have completed?
There's one installed project. My job is to fill up the factory, and we have a few more going into the field in 2026. And so we're pretty excited about those projects. But yeah, to answer your question, as of today, there's only one unit running.
Great. Well, Chris, thank you so much for your time and for the information that you've provided. Thank you, everyone, for attending today and the insightful questions that you've provided. We hope you can enjoy us. We hope you can join us for future presentations. And thank you very much for your time today.
Thank you, everybody.